Okay. Regarding on this topic, equilibrium and free body diagram, anyone here want to ask question before I continue with our discussion? Please, if you have any question, because this is the basics of statics. I'll try my best to do this as slow as possible. Actually, it's not slow, but I mean, like, I will try to accommodate all of you guys. So I want to ensure that all of you completely understand about the current topic. Because if you don't understand the current topic, the next and the one after, okay, it will be too difficult to follow. So this current topic is very important. That's why I want to make sure that all of you understand what. Okay, any question about this topic, equilibrium? Or should we start with quiz? Okay, actually, I will try that. Any question? Okay then. In that case, I will give you option. Give me a question, or else I will assume that you completely understand about this. Then I will give you quiz straight away right now. No one want to ask question? Seriously? So you guys prefer quiz then?
I don't know what I don't know, sir.
You don't know what you don't know. What do you mean by that?
As of right now, I think I understand, but I don't know if maybe I don't know something.
Okay then. In that case, it is better for you to practice more like that. You mean?
Sir, maybe if we do like a questions together, then the question will arise.
Okay.
Yeah, but I think an open discussion could like memicu trigger something.
Just like yesterday, Pak, you choose one people and people will wake up.
Okay. Okay then. In that case, we will continue with our problem example. But if at the end of the class, we will finish the class with a quiz. Can you handle that, guys?
Not sure, sir, but
Not sure,
let's see.
Okay. In that case, because today we will concentrate on the problem example, and I believe most of the problem will be handled today, and some other problem I will give it via I will give it as your homework like that. Okay. So the thing is, next week on Thursday, we will start the class with a quiz. Okay. Is it understood, guys?
Yes, sir.
Quiz of the previous topic, sir?
Yeah, no. Until today's topic. So the whole things that we have learned until today, like that. Okay. So about most likely it will be more to the equilibrium and free body diagram. So quiz about that. But in order for you to handle equilibrium and free body diagram, right? It is not possible for you to just study equilibrium and free body diagram. You have to study the previous one as well. You have to study about the moment. You have to study about the resultant, like that. Okay, so actually it's the whole thing until free body diagram and equilibrium. Okay, so I will start the discussion for today. Maybe we will start with a simple one. Okay, I think I will. Okay, yeah. I remember right now. Okay, I remember yesterday there is somebody who told me that it's very hard for her to wake up early. I forgot the name.
Shabina, sir.
Yeah, Sabina. Oh yeah, Sabina. Where's Sabina? Hello, Sabina. Still not wrong. Yeah. Okay, still not wrong. Sabina is still not wrong. Okay, yesterday I believe the last problem that we handled together, Nia helps me to do that, right? So who else here? Omar. I think I rarely hear your voice, Omar. Yeah, I want you to help me, Omar, to try to solve this particular problem. This one, actually, maybe we can consider it as one of the simplest problem in statics because you can see all the forces are happening at the same point. So how can we draw the free body diagram for this kind of case, Omar?
I think we use point C as the center where all the force is, where we draw all the force, sir.
Okay.
Because that's where all the force merge together.
Okay.
And then we draw the force.
Something like this. This is point C. Yeah. It's always like that. Clear. Stop share. Sorry. Start now. Okay, so this is it. You mean point C? Yes, this is point C. And then what else are we supposed to do, Omar?
We draw the force vector, sir.
The force vector of what?
Maybe to make it easier, we draw the force vector of AC and BC first.
AC and BC, and where? Before we go there, okay, Omar, can you explain to your friend actually what variables that we're supposed to solve here?
Tension, sir. Wait.
This one, right?
The variable, sir.
Yeah, the variables that we need to solve.
The tension of AC and BC, sir, because the tension and CD are already determined because it's the same as the mass times gravity.
Correct, Omar. Okay, so these two variables are not yet known, but FCD, just put it here. But FCD, we know it already. FCD, this is C. FCD, we know it already. And what is the value of CD, Omar?
It's the
30 kilograms.
Time gravity 30 kilograms times 10 or 9.8.
It's better for you to always use 9.81.
Oh.
Okay. So the results it's quite close to 300 newtons, right?
Yes.
Okay. And that's we know the value already. We know the value of F. We have FAC and FPC is not yet known. So then I'll cross this and I will withdraw graph here. So this is point C. Okay, FAC. Where's the direction of FAC?
FAC, it's direction of AC. I think it's like the opposite. The direction of AC is the opposite of point C, so it points to the opposite, points to A.
Correct. So just follow the rope actually. Okay, we just need to follow the rope. So this is the same, exactly the same as the rope. FAC. Okay, must be tension. Why tension?
Mm,
Can you imagine a rope, Omar?
yes.
Can a rope withstand compression?
Compression. Maybe.
No. Rope. Okay. I will give you an example. This is my earphone. Right? Yeah, it looks like a rope, right? Okay.
Okay.
If I pull it, you can see it. If I pull it,
Yes.
it can withstand it. But when I compress it, what happened here?
It
It
became.
Okay. So whenever we talk about cables, whenever we talk about ropes, okay, guys, okay, it can only withstand tension. That's a special case. Okay,
Okay.
that's why the direction must be like that because it's tension.
Okay.
Okay, man.
Okay, sir.
Now, please tell me about the direction of FBC. FBC, this one.
FBC. It points to the B from
B.
C to D.
So it's supposed to be like this, roughly like this. Okay. But remember, you have to give information about the angle. Okay. So if I draw, if this one is alpha and this one is beta,
Mhm.
can you tell me what is the value of alpha and what is the value of beta?
Oh.
It's not that hard.
Alpha is
The easier way
30,
to draw
30.
the 30
Alpha.
alpha.
Eh?
No, try to draw it in the main in the main body.
45, sir.
So-
45.
Yeah, this one is
45.
alpha, right?
Oh yeah.
Right, right? It's supposed to be 45. I believe Omar is not yet completely wake up, right, Omar?
No, I just thought it's oh yeah. I get it. I just thought it's switch because the degree is changing from A surface to C.
Yes, of course. It's supposed to you're supposed to swap that, but the total is supposed to be 90 degrees, right?
Yes.
Yeah, 45 plus 45 is 90 degrees. So alpha must be 45, right?
Oh yeah.
Okay, now this one is beta. What is the value of beta?
Beta is 30 degrees.
Nah, no,
60, sir, 60.
no. 60.
60. Oh.
Remember, whenever you talk about triangle, right, the total angle of the triangle is supposed to be high, 80 degrees, right? So this one is 90 degrees. This one is 30 degrees. Beta here plus 30 degrees must be 90 degrees, right?
Oh yes. So
So it's
I get
supposed to
it.
be 60 degrees. This is basic trigonometry, right?
Yes.
Okay, now the last one is the known value. We have FCD, but we know the value, so we don't put it as FCD, but we can put it as 30 kilogram multiplied by 9.81. What is the value? 290 something, right? What is the value? Can you?
94.3.
Sorry,
290
290.
94.3.
94.3 Newton. Okay, because this is 294.3 Newton. Now the last one. This is the because we are drawing the free body diagram. So the last one, this one. What is the angle there? For 294.
15 degrees.
15 degrees. 15 degrees. Correct. This is it. This is your complete free body diagram for this particular case. Okay. Do you get it, Omar?
I understand, sir.
Okay. Now, the question is, we have to find the value of a FAC, and we have to find the value of FBC, right?
Yes.
How to solve that?
I think we divide the we divide all the force vectors into force component like fx and fy.
Yes, you can do it that way. So what should we do then?
Uh,
Okay, remember,
Uh.
whenever we try to solve it, Omar, yesterday I told you, right, about the sequence that you're supposed to follow. I'm not kidding about the sequence that we're supposed to follow this one. First is to draw the free body diagram.
Okay.
Then identify the known and unknown variables. These
Okay.
two, we have done it, right?
Mm.
We draw the free body diagram. We identify the known and unknown variables. The known variable is 294.3 Newton. It's supposed to be I forgot. FCD, right? FCD, we know the value. The unknown values is the rest, FAC and FBC, right?
Yes.
So this one is done as well. In order for you to find a solution, what remaining steps that you're supposed to do?
Oh,
This one, right?
Yes, implement first and third Newton's law.
Actually, this one, the meaning of this is actually you can just implement this for two-dimensional problem. Okay, two-dimensional problem. You just need to implement this. Sigma fx equal to 0. Okay.
Oh, sigma
fy equal to 0. And the last one is sigma moment at any location that you want equal to 0.
0.
Okay. Now, what you should do to solve for this problem? The remaining step. Remember the remaining steps that you're supposed to do. You have to do this, right? Use this, right?
Yeah.
Fx equal to 0, sigma fy equal to 0, and sigma moment equal to 0, right?
Yes.
Okay, now my next question is, sigma moment equal to 0, can we use that or not? All the forces are happening at one particular point.
I think we can use that.
No,
sir.
we can't. we
There's
can.
no distance being described in the problem, so I don't think so.
Because no moment is there. All the forces are happening at the same point, C. When everything is happening at the same point, okay, there will be no moment arms, Omar. You get it, Omar? So we can't use this.
I see.
So we are left with these two remaining equations.
Okay.
Do you get it?
I get it.
Okay, now try to implement sigma fx equal to 0 then.
Like I say, divide the force into fx component and fy component.
Okay, now x component.
X component, it's
Okay, now before that, okay, always start with this. Before that, you want it to be going right positive or going left positive for sigma fx.
Right positive.
Okay, right positive. Then stick with it. Okay, now right positive. Please mention all the forces in the sigma fx equal to 0.
It's wait. The 294.3
Okay, 294.3
cos 15
Newton.
cos 15 degrees.
Okay, cos 15 degrees, correct. Positive or negative?
Positive.
Okay, then
minus
correct.
Minus FAC
Multiplied by
cos 45 degrees.
okay, cos 45 degrees. What else?
And then minus FBC. Cos 60 degrees.
Cos 60 degrees. Then?
Yes. That's all, sir.
No, it's not. That's all. This is not an equation. Remember, we have to represent this.
Equals to 0.
Okay. Yeah, correct. That's the first one. Hold on. Now the second one, sigma Fy equal to 0. All the vertical components. But before that, always you're going up positive or going down positive?
Up positive.
Up positive. Okay. Then B constant. What is the equation then? Which represents sigma Fy?
And it's 204.3 sin 15 degrees.
Positive, negative?
Positive.
It's going up. Okay, correct. Yeah.
And then plus FAC.
Okay, plus. Okay. Plus
Plus.
FAC.
FAC.
Because it's going up, right?
Yes. Plus FAC sin 45 degrees.
Okay, then
Minus FBC. Sin 60 degrees equals 0.
so we have this two equation. Okay, Omar. Now I'm asking you, how many unknowns do we have?
I'm sorry, sir.
How many unknowns do we have?
Unknowns. Unknowns.
The unknowns is FAC and FBC. Yeah?
FAC and FBC.
How many are those? 2. Right?
Yes. 2.
Okay. How many equations that we have right now?
2.
2 equations as well. Can we solve it?
Yes, sir.
Yes, we can solve it. You can see it. As long as we do a substitution or elimination to these 2 equations, okay, we can solve for FAC and FBC. Do you get it or not?
I get it, sir.
I will not calculate it in front of you guys because this one is simple. You can find by yourself and let me know what is the result. Anyone here have calculated? Omar, have you finished calculating?
No, sir. Not yet, sir.
Okay, not yet. Anyone here has finished calculating? So later in the video, you can your friend can recheck for it. Anyone here? Sig, have you finished it, Sig?
Pardon, sir.
You're supposed to follow as well. Don't
Yes.
just sleep, return back to sleep.
I'm
Unless-
almost finished. Almost.
Almost finished. Okay, good. Jovan, have you finished, Jovan?
Sorry, sir.
Have you finished?
Yes.
Yeah. What is the value of
So is
FAC and
it
FBC?
safe to assume that FAC
Oh,
and FBC
Calculating
have the
this
same,
one, I haven't.
Yes, of course. So wait.
I thought the homework.
No, it's
sir,
not. Yep.
sir, is it safe to assume that FAC and FBC has the same magnitude but are only like different by their trigonometric ratios because of their trigonometric ratios, or am I wrong?
It is assumed. It is safe to assume what?
That FAC and FBC and the equations below, they're like the same but only different because of their trig ratios.
No. We not necessarily always like this.
Oh,
So
I see.
all it's not necessarily always like this. This is just spatial case because everything is going to just to the same point. All the forces are going to the same point. That's why we have it this way. But sometimes it's not necessarily like this. So always try to analyze case by case like that. Okay,
Okay.
Azab? Yep.
Okay, sir.
Sir.
Mhm.
I think I found it.
Yeah, what is the value? Wait.
For
Let me. What is the value?
for BC, I think it's 260.
Wait a minute. Let
3.
me return back to this. FPC is 300 and what?
263.
263 Newton. How about FAC? Hello, Zik.
Hello, sir. 215, sir.
215.
But somebody can correct me if I'm wrong.
Okay.
It's correct.
Okay, good. So something like that. This is one of the simplest problem in statics because all the forces are going to one point, which means there will be no moment there. Okay. Anyone here still having a problem with this particular problem? This particular problem is simple. If yes, please let me know.
Excuse me, sir.
Yep, Irfan.
Can you repeat the first steps in order to find the the forces? I think
The first step is supposed to draw the free body diagram. Irfan. This one.
okay.
Drawing the free body diagram is the first step. After you draw the free body diagram, you can see that which variables is known value, which variables is unknown value. Okay, for us, FCD here in this location and here, okay, is known value because we can get FCD directly from the mass, the kilogram here. So the value of FCD is 294.3 Newton. So it's known value. Okay, the remaining variables, FAC and FBC, are unknowns. Okay, so the second step, okay, after drawing the free body diagram, is determining which variables is known values, which variables is unknown values. Do you get it, Irfan?
Yes.
Okay.
Sir.
Then the third step, which I told you before, is to use the first Newton law and the third Newton law. But basically, what you're supposed to do is just implementing this implementing these three equations for two-dimensional case. Sigma fx equal to 0, sigma fy equal to 0, and sigma moment at whichever location that you want equal to 0. Okay.
I see. Yes.
After by implementing this, okay, you will be able to solve the solution just like what we did right now. Okay, you get it, Irfan?
Yes, sir. I was a little confused for the CD, but then
Okay.
yes, you just need to multiply it.
CD, you mean? Oh, okay, FCD, you mean? FCD, yeah.
Yes.
Because you
Yes,
can get it directly. Right? 30 kilograms there, it's going down, right?
Yes, sir.
30 kilograms going down, so roughly around 294.3 Newton is going down. So basically, if you want to draw it as well, you can. If we want to see this particular free body diagram, you can, but it's not compulsory. So it's something like this. If I want to draw the free body diagram of that particular pulley, it will be like this. Okay, this is the pulley. And this is the first CD. And this is the weight. The weight is 30 kilograms. So 294.3, right? Yeah, 294.3 Newton. Then there is action and reaction. There is reaction at point D. So dx and dy there. So this is actually the free body diagram of the pulley. Yeah. This one of pulley D here. Do you get it, Irfan?
Yes. Yes.
Yeah.
Sir.
Actually, how can we get FCD is equal to 294.3 kilonewton is from this free body diagram. Just now what Asir did it, what Omar did it is directly. So we solve it directly because we can see that the FCD there, it must be the same as this one. But actually, if you want to do it step by step, you can do that as well. How can we do that? Okay. we
Yeah.
can just solve
Yes, sir.
this particular free body diagram first before we go into the next free body diagram, because sometimes, okay, before we go into this particular free body diagram, so we can solve two free body diagrams to solve for the whole problem, because sometimes we have to divide the system into several free body diagrams. This is one of the cases. Although the first pulley, the pulley is simple, so sometimes we can solve it directly inside of our head. But if you want to do it step by step, you can as well. This is the free body diagram. Do you understand why the free body diagram is like this, Irfan?
Yes. Yes, sir.
Dx and dy, where did you get it? Where do we get it from?
Dx and dy, because there are we must divide it into the x-axis and y-axis.
Yep. So it's happening because of the forces there.
The forces because of the weight. The
No,
30
it's not.
kilograms.
It's not because of the weight. Dx and dy. It's happening because there is a pin here.
Oh, I see. Yes, sir.
Okay. So it's the reaction force. Dx and dy is actually the reaction force. Because of 30 kilograms, is this one.
Yes, sir. So there must be a reaction force.
Yep, the reaction force at the pin, it's dx and dy. And the first thing that we're supposed to find is FCD. How can we find FCD? Actually simple. Just use sigma moment at point D equal to 0. Then, in that case, we will find that it's supposed to be 394.3 Newton multiplied by its radius minus FCD multiplied by its radius equal to 0. Later, our results here will be FCD equal to 294.3 Newton. But sometimes we can do everything inside of our head because it will be just the same for pulley like this. Do you get it? Irfan?
Yes, sir. Yes.
But basically, the first step, if you want to do it step by step, is solving this first. Then, this is our first one. Then, solving this one. This one is our second case. This one, sorry,
And,
the free body diagram.
sir,
Mhm.
I want to make sure, sir, the direction for the ropes of AC and DC, it's that way because is it because tension is always away from the point, or the direction
Tension
for
is always
AC?
away from the point. Going away from the point.
right?
Yeah, because
I see.
you can imagine, right? If this is our pivot, like here, this is our pivot. If I pull it like that, pull it going there. So the force which will be happening at the pivot will always go like this, right? Going there, right?
Yes.
Going away from the point.
Yes, sir.
Okay, the same as this one. This one is FCD is tension, right? It's going away from the point.
Yes.
But because FCD here and FCD here in this plate, in this part, is action and reaction, the direction is complete is 180 degrees. FCD in the second free body diagram is going to the top right.
Yes.
FCD in the first free body diagram is going to the bottom left. Right?
Yeah.
Yeah, because that we are looking at the point of each. The first one is we are looking at the pulley, and the second one we are looking at the point. So we are not looking at the rope itself. Do you get it?
Yes, I understand, sir.
Okay. Any question here? Any more question in this particular problem? No.
Sir, in the last step, we eliminate it immediately, right? Yeah, sir. Just eliminate substitution and the
Oh
slide.
yeah, this one. You mean this one, right?
Yes.
After we have these two equations,
Yes.
you can
Yes,
use a substitution or elimination or both, as long as you can get ABC and FAEC and FBC.
Okay, sir.
Okay. Now the next one. This is our next problem example. Okay. The first thing that you're supposed to do now. Shabina was late. Oh, it's okay. Okay, everyone. Now the next thing that we're supposed to do is to solve for this. We want to solve for this particular problem. So the first thing that you're supposed to do is try to read the problem, try to understand it, and then after that, we will solve it together. Okay, the first thing that you're supposed to do is to understand it. So I will give you like around 5 minutes to try to understand it, and after 5 minutes, we will try to discuss it together. Okay, is it understood? Hello?
Yes, sir.
Yeah, okay, good. I will pause the recording first then. Gaza, please help me to solve it then.
Okay, so according to first step is to draw the free body diagram.
Okay, so, which
let's
part
just
of the
assume
current
that,
is supposed to draw then in the case?
let's just determine a shapeless shaft, like a line, for the free body diagram for the car.
No, actually, it's better for you to draw the car as well.
Oh, I see.
So at least the outer shape of the car.
Okay.
No, it's okay. So it's like this.
Yeah.
But I want you to help me to determine. Yeah, actually, you don't have to draw it there, good like that, because I've never been a good good artist as well, and I can still manage to graduate from IDP. So you don't have to worry about it.
Okay.
Okay. Yeah, something like this. Okay.
Yes.
So
Yes.
what forces is in order for us to draw the proper free body diagram, you're supposed to draw all the forces there and all the dimension actually. So what forces do we have there first?
First we have the weight force from the center of gravity in G. In G, which is
correct.
about 45 inches from point A, which is the front wheel.
Right. And what is the
It's down,
value then?
3600.
3600. And what is the unit?
In
What's that?
pounds, LB. Pounds.
Pounds. Remember, please differentiate between this. And I believe Pak Pulung told you about it in Introduction to Engineering and Design, right?
Yeah. So it's
what's the
pounds
difference
force.
between these two?
M is pounds mass.
This one, the first one is pound mass. The second one is pound force. And if we are talking about mass, it's supposed to be pound mass. But when we talk about force, we're supposed to use pound force. In this case, it's LBF, right? Okay.
Yes.
What else?
And then there would be the weight from the load, which is behind the back wheel.
Okay.
About
so
15 inches.
Roughly here. Okay.
Yeah.
Okay, roughly here. WL. Do you have the value for WL?
That's the one we're going to count for.
Okay.
And then we have the.
And the X is. Oh, sorry. Just now I forgot about something. So here, the distance here. So I have to put it like this. Okay, like this. So the distance here is supposed to be just now 45 inches. Okay, the distance here, yeah, I just completed, try to complete 67 inches. And the distance here,
16.
16 inches. Okay. Beside WL and 3600 lbs. What else do we have?
Normal forces on point A and point B, which is in the left side of the 45 inches and in the right side of the 67 inches, just before 16.
And we're supposed to put the direction as well. There.
Sorry?
Where's the direction?
Upward.
Where's the forces going? Upwards. Okay. So we can draw it like this and like this. Okay. Okay, then I will do it. I will name it as NA and NB like this. Anything else?
No.
Asad?
No, I think that's all.
No. Okay. And this is the first step, right? The second step is we have to know, list out what is the known value and what is the unknown value. So we have here known value, 3,600 pound force. How about the unknowns?
The unknowns are the normal forces, which are supposed to be equal in the NA and the NB.
Okay.
And then
Supposed to be equal.
Yes, according
So
to that problem.
NA, okay, NB,
And also
so-
the weight of the load.
well, okay. Then we have one data as well, that
Which are the distances.
normal force under the front and the rear wheels are equal, right? So in that case, we know from the beginning that NA is equal to NB, right? This way,
Yes.
like this way. So in that case as well, we don't have to put everything as NA and NB like this. So we can just later replace one with the other one. So we can just put it like this, NB equal to NA, like that. So everything later, or all of our calculation later will be in NA, right?
Yes.
That's it. Okay, now how can we solve it, Azar? The next thing, after listing out the unknowns and the knowns value.
In the previous problems, like the ones in the one in the homework, we would evaluate for the resultant force first. But since that is what we're going to find in this, we would evaluate the moment first.
Okay, yeah, you can do that. But
solve for
before we going for that, it is better for us to list out the equation, the possible equation that we can use. Start with that. Always start with that.
Yes.
So always, right? Sigma fx equal to 0, sigma fy equal to 0, and sigma moment equal to 0. Then after that, try to check whether any of this equation is not available for us. Which one do you think that is not available for us?
Sorry, on what?
Which one do you think that is not available for us to solve, to be used to solve this particular problem?
One, sigma, since there are no other external forces acting upon the x-axis, I think sigma fx0 is unavailable.
Correct answer. So now we have two available equations. Sigma fy equals 0 and sigma moment equals 0. Okay, which one do you want to use first?
Sigma m equals to 0.
Sigma moment equals to 0. Against which point? I said.
From point A.
Point A, okay. You can do it that way. So sigma moment at point A equal to 0. And what is the results of the equation? Not the results. If I want to list out all the variables there for that particular equation, what is it?
I think first would be, I think it's kind of like trivial. And equal n times 0. I think we should include it just for, just to say that we consider the normal force at point A, and then the
Actually,
next one
NA
would be,
multiplied by 0. Okay.
Yeah.
I said the previous the yesterday's case, right? Actually, when I told you about yesterday's case, it's just like an example. In order to make sure that you all understand that when the perpendicular distance is 0, there will be no moment there. So if you
Yes.
know it inside your head, actually, it is not necessary for you to write it down.
Oh, okay.
So so NA multiplied by 0, you don't have to write it down.
Oh,
But
alright.
if you want to write it down, it's okay as well.
Okay. Okay, for simplicity, I think
Okay,
we'll
so-
just carry on to the next one. It would be the 3,600 pound force
Okay.
downward
Multiply
pound
by
force times 45 inches.
45 inches. What else? Yeah, forgot.
And then
Always
the next
start
one
with.
be the
Sorry, I said you forgot about something. This one for sigma moment, you have to determine first. Sigma moment, the moment positive is clockwise or anti-clockwise for this particular calculation.
I would pick the downward direction as
Okay.
the positive. Oh,
Moment is clockwise or counterclockwise?
oh, clockwise is positive.
Clockwise, positive. Okay, it's up to you. So this one is
Yes.
okay. Then, if 3,600 lbf multiplied by 45 inches, it's supposed to be clockwise or anti-clockwise?
Clockwise.
Clockwise, so it's positive, right? Then what else?
And then the normal force at B, that would be anti-clockwise. So we would subtract it from
Negative.
it. So minus n equal times 112 because it's 45 times plus 67.
NA or NB?
And NB, but it doesn't matter because they're the same. So we just
Yeah,
write
but
n.
it is better for us in this case because we are trying to use NA for all of our calculation in order for us to reduce the number of unknowns. Okay, so we stick with NA.
All right.
You get it? Because
Yes.
if not, later we have 3 unknowns. But if from the beginning we just use NA here and NA here, we will only have 2 unknowns
Oh, I see. Okay.
in our calculation. Okay, so NA multiplied by
112.
112, yes, correct. 112 inches. What else?
We would have a clockwise moment from the
WL.
load weight, the WL, which
Plus
is
10 multiplied by
112 times plus 16, 128.
yeah, correct. 128 inches. What else?
And that would be all. And they would be the result of this line of work would be equals to 0.
Okay. Good. So the next equation that we're supposed to use is what?
The next one would be the sigma Fy equals to 0.
As usual, going up or going down is positive.
Point down would be negative and point up would be positive.
Going up, positive. Okay, what we have there?
We have the NA plus, we have 2 NAs because
Okay.
NA and NB is the same.
So NA, 2 NA. What else?
And we have the downward 3,600 pound force.
What else?
And we would have the
Downwards.
downward load weight. Yes.
Okay, equal to 0. Like this.
Yes.
Now we have 2 equations there. This is the first equation and this is the second equation. And those 2 equations have from those
Same
2
variables.
equations we have 2 unknowns, right?
Yes.
So we can solve for both. Okay.
Yes.
I think I will try to solve for both, right? 3,600 multiplied by 45. Okay. 3,600 multiplied by 45 inches. Let's know what is NA 112.
162,000.
and A my 112. Then what else?
The weight of the load.
WL
Yes.
plus WL multiplied 128 equal to 0. This is our first equation. Yeah. Then 2NA minus 3600 minus WL. Okay. 2NA minus 3600 minus WL equal to 0. Okay.
Yes.
From this, what you can do is you can use elimination or substitution. Okay, then I will use elimination, for example. This is my first equation, and this is my second equation. This is just example for you guys, for those who still confused about elimination and substitution. I will use substitution here. In this case, I will try to find a relation between NA and WL. Okay, what we have here is 2NA from equation 2. Okay, I will have 2NA equal to WL plus 3600. Correct, right, Asad?
Yes.
Okay, so NA will be WL plus 3600 divided by 2. So this one is divided by 2. So this one is will be 1800.
Yes.
Yeah. Then I have this NA equal to something, right? Then I can substitute. This one will be my equation, which will be substituted back to this, the first equation. Okay. So later I will have like this 3600 multiplied by 45 minus NA. In this case, I will replace NA with WL per 2 plus 1800. Okay, multiply by 112 plus WL multiplied by 128 equal to 0. In this particular equation, we only have one unknown, WL, so we can solve for WL. Okay, Asher, please help me to calculate this. What is the value there?
162,000. 162,000. 62,000. Yes.
Okay. Then this one is supposed to be minus 56 WL plus 1800 multiplied by 112. What is the value there?
201,600.
201,600.
Yes. Yes.
Okay. Plus plus 128 WL equal to 0. 128.56. So 72 WL. Yeah. 72 WL will be equal to 201,600 minus 122,000. Okay.
Yes.
So what is the value of this calculation?
39,600.
39,600. Right, divided by 72.
That would
So
be
our
550. 550.
550 LPF. So is this is the question they asked. Yeah. Why I cannot go to the previous one? Determine the WL for which the normal force under the front and the rear wheels are equal. So the one that is asked is only WL. So this one is our answer. Okay. If you are still confused, if you guys, any of you still confused about how to do the elimination and substitution, that's the way to do it.
Amazing, sir.
Amazing. Amazing.
I want to ask something.
Mm-hmm.
Can you back to the slide before this?
Okay, by the way, thank you, Asad. Yeah, for helping. Yes. Okay,
Yes,
this
sir. Yeah, the one that I want to ask how to determine that NA and V is equal.
Sorry.
How
It's
how
stated
can how,
key.
how can which one is stated?
Normal forces under the front
Normal
and
force
rear
under the
wheels are
front.
equal.
The last sentence.
I see. Okay, but I didn't read that last sentence.
Okay. Yes, support. You're
Sir, I
supposed
have
to
a
read it
question.
carefully, risky. Okay. Yes, Matthew.
I found, may I relocate the forces into the center of gravity? So I'll get the comparison of the normal force and weight, and then I'll input it to the sigma F equation. Instead of doing substitution, can I do that?
Wait. Can you replace the force? Which one? WL.
Instead of putting all the forces into one end, I put the forces into the center of gravity.
You
So
mean
I
the
should
sigma
not.
moment?
Yes. So the sigma
Yeah,
moment
sorry.
will turn about the center of gravity.
The result will be still exactly the same. I think.
So it's fine, right? So I don't have to do substitution
Why you don't have to do substitution? Then?
because using the sigma moment at the center of gravity will not have will only have the comparison between the values of NA and the way.
Just the same with this one then. This one is just the same. Or you mean there will be no number at all like that? So you can just but it's just still the same. The calculation is still the same.
I mean, is that fine? Because it's
It's
easier
fine,
for me.
It's fine. So actually, it's actually like this. The basic concept is you can use any whatever problem you want to solve for one free body diagram. Okay, in two-dimensional case, we can use sigma fx equal to 0. We can use sigma fy equal to 0. We can use sigma moment equal to 0. This one, those two are fixed. So we cannot change it out because we have to consider the whole forces which is happening at the free body diagram. In the x direction, this one, and in the y direction, this one. But okay, for sigma moment, okay, you can do whatever you like with that. Okay, for example, you can use sigma moment at point A, like what Asia did just now. Or you can use sigma moment at the center of gravity, like what you want to use just now. Or you can use it at point B as well. Or you can use it at the end as well. It's up to you. There will be a positive and negatives using each of those. So it's up to you. If you use it at the end like this, there is one positive thing. In the sigma moment equation, there will be no WL. So all the equation will be in normal force, NA. In that case, you will be able to get the value of NA directly. So there will be always positive and negative things for that. Okay, Matthew? So you can do whatever you like, but try to analyze the problem. Which sigma moment, which point, which pivot that we can use for the sigma moment that can give you the most advantages. Okay, Matthew?
Okay, sir. Thank you, sir.
No problem. Any other question here?
Excuse me, sir. May you repeat on how to find the moment?
No, not how to find the moment, but how to choose the pivot. So for this one, sigma moment, whenever we want to use sigma moment, you can choose whenever pivot that you want. Okay, fine. You can choose whenever pivot, wherever pivot that you want. We can choose point A. You can choose point G as pivot. You can choose point B as the pivot, or you can choose C as pivot. But what you're supposed to keep in mind is whenever we have to choose a pivot which will give us the most advantages. Although solving the problem using any of this pivot, it will still work. So any of these pivot will still work to solve the problem. But some pivot will give more advantage than the other pivot. Do you get it, Fred?
So, yes, Pak. So in this case, why is it 0 again, Pak? For the moment of A in point A.
Yeah. Point A, what?
Yes. Why is it 0 again? Why is it
0.
equals to 0?
Oh, this one, sigma.
Yes.
Irfan. Okay. Sigma moment equal to 0, sigma fx equal to 0, sigma fy equal to 0.
Oh, I see.
Equilibrium equation that we're supposed to fulfill. Okay. For the static case.
Wait, sir. So, so this is for pretty much like it must be sigma moment equals 0.
Yes, all the cases, all the statics cases, we're supposed to fulfill this, all the statics. You know statics, right? Static is not moving at all. Okay.
Yes.
Whenever it's not moving at all, in the two-dimensional case, this equation must be fulfilled.
I see. Yes, sir.
So it must be 0. If it's not 0, for example, if you are inside of a building and this equation is not fulfilled, okay, the building will move. The building will move. You want that?
Yes, sir.
Oh, you want that? No, you want that?
No, sir. No, sir.
So it must be fulfilled. So the 0 comes from there. It's actually it comes from the first Newton law. Okay, so if you ask me, this must be 0, this must be 0, this must be 0. So the equation must be like this. Okay, but sometimes some problem we cannot use the equation. For example, this particular problem for this particular free body diagram, second free body diagram, we cannot use sigma moment there because there is no moment arm, so we can only use sigma fx and sigma fy. Okay, but the sigma moment equilibrium is still fulfilled there. Okay, but we cannot use the equation. Okay, the same as this one. There is no horizontal forces. That's why we cannot use sigma fx equal to 0. This one we cannot use. But the equilibrium in the x direction is still fulfilled. That's the thing. You get it, Irfan?
Yes, sir. I understand. Okay, thank you, sir.
No problem. Anyone else want to ask question?
Sir, is there a way to pick the best pivot?
By experience, Matthew. So when you practice more, you will realize which pivot will give you the best results. Which pivot will give you the best advantage.
Best pivot is where all the forces in that point.
Not necessarily. Sometimes we have to choose the best pivot. We have to choose the pivot which can reduce the most unknowns. For example, if I were you, I will not use pivot A. I will not use pivot T. I will use pivot where the WL works. Because by doing so, using sigma moment at the point of WL, I can get the value of NA directly without substitution or elimination. Then that value, I can use it in the sigma Fy equal to 0 to get the WL. But everyone has their own preference, right? So it's up to you guys. you want the long way,
I think
or you want the?
I think that's the nicest, sir, for this question.
Yeah, but actually there is no 100% for that. I can do that because I have more experience than you guys. But I'm telling you, anywhere there, so point A, point B, point G, or at WL, all of those sigma moment at all of those points, okay, but you can only use it once, okay. if you use sigma moment at A, or you use sigma moment at G, or you use sigma moment at B, you can only use it once. So whichever of those, okay, wherever you use, okay, you still can solve the problem. The question is whether you solve the problem with more calculation or with shorter calculation. That's the thing. Okay, so you don't have to worry about it. By practicing more, you will get that. You will get that. Yeah, that's it, fun.
Yes, sir.
Pak,
Yeah.
so if there just in the case a single fx in this image, we need to account this to sigma fx equal to 0.
Sorry. If we
jadi kalau emang
on...
kalau ada fx aja 1, kita harus consider fx sama dan 0.
Yes, correct. But if just one force in the x direction, I can assure you that one particular force will be equal to 0.
Okay.
Because like it or not, you have to fulfill the sigma fx equal to 0, right? Risky. So sigma fx equal to 0, only one force. So that force will be equal to 0.
Yeah, right.
Yeah. Okay. I think I will continue with the next problem. Maybe this is the wait. Let me see. Better for us to do this or to do this first. I think we can do both. Okay, just fast calculation. Okay, let's try to solve this. Okay, for anyone here who can solve this in less than 2 minutes, okay, from now, okay, the next quiz I will give him or her 100 marks without him needing doing the quiz. Interesting, eh? How about that? Risky? Can you do it, Risky?
I need to look at this first.
Okay, so 2 minutes from now. Okay, so you guys can think about it. 2 minutes from now. Okay, but I think I will post the recording first. Then, anyway, Yep. So actually, if
can you go to the next slide?
Wait a minute. I'm so sorry that later when you watch the video, it will be to jump forward like that because the video for this is just now I posted. But anyway, the way to do it is like this, and if you want to neither solution, actually the book have it like this. Yeah, which one that you want to ask?
So kan we already found the CX and the CY. So the next thing to get the final answer is to find the resultant. So the final answer is the resultant.
Find the magnitude and total force. Yes, actually,
we need
the resultant.
to find the resultant.
Actually, you can write it like this, or you can write it as the resultant's total C as well, equal to 217 square plus 125 square as well. Yeah, it's supposed to be okay.
So if it's easy, solving until CY and CX is already good.
Normally, solving until CY and CX is supposed to be okay.
Okay, thank you, Pak.
Sir, would I also get 100 like Nuki, sir?
Nope. The first one, only the first one.
Not me, Pak.
Oh, man.
Aduh. I'm looking for the next question for next week, Pak.
Okay. forget that. Anyway, that's supposed to be it. And I will give you some some homework after this. Okay. And actually, I want to discuss a little bit about this kind of problem. If you have this kind of problem, how can we draw the free body diagram? The question here is to find out the moment happening there, because it's welded. Welded means whenever we say that it's welded, it means that the welded pin or anything that is fixed, it can withstand, besides the Fx and Fy as a pin, it can withstand moment as well. So this kind of moment and force combination can replace the welded pin or the fixed what you call it, fixed constraint. Okay.
Sir,
So,
what do you mean by can withstand moment?
So whenever we talk about try to imagine if a pin is welded, means that it can withstand moment, so it will not be able to be rotated. Do you get it? So because if it's not be able to be rotated, then it can withstand moment. So whenever we have this kind of constraint, or whenever we have a fixed constraint, okay, we have to draw it like this. Okay, we have a fixed constraint at the left edge, for example. We have to draw it like this in the free body diagram. Fy, Fx, okay, because it will not be able to move at the x and y direction. Then beside that, so moment, because it will not be able to rotate as well. Do you get it, guys? So we're supposed to draw the free body diagram like this at the left edge. Look, answer please. Don't just stay quiet like this. Hello, guys.
I'm thinking, sir. I'm thinking.
Oh, you are thinking. Great.
So it's like moving the pulley to A.
Movie? No.
Is it like?
I'm just talking about this particular constraint. So I haven't talked about this yet.
Okay.
So the left edge, the
Okay.
constraint at the left edge, we're supposed to replace it with forces and moment like what I draw here. After that, of course, there is a mass of the beam. So we have roughly 200 G there, so it's roughly 2000 Newton. What else that we have is we have a man, 8 kilograms man, so roughly around 800 Newtons here. Okay, then the man is exerting 300 Newton. So pulling it, the man is pulling the rope. Okay, because the man is pulling the rope, actually you guys are supposed to draw the free body diagram of the man first.
Sir, so what you're saying is the pin also acts the force, yeah? Also a moment.
Yes. Just now, yes.
Oh, I see.
Yep. But when we are talking about this particular man, okay, the man will get a normal force from the pin. The man has its own weight, 800 Newton. Normal force from the beam going up. What else? The man is actually exerting 300 Newton, right? Because he exerted 300 Newtons. It means that he's being pulled by the rope. So there will be 300 Newton as well going down, besides 800 Newton going up. So they are double there. Okay. 800 Newton going down, 300 Newtons going down. Then normal force. Okay, because of that, using sigma Fx equal to 0, then we have normal force is equal to 800 plus 300 Newton. Okay, so actually the normal force here is supposed to be 1100 Newton. So it's not supposed to be 800, but 1100 Newtons. What else? There will be another 300 Newtons here. So basically, this is the free body diagram for the beam. And this is the free body diagram of the man. Although I haven't put the dimension yet, yes, there. You're supposed to put the dimension there.
So sir, we need to make two body diagrams if there's a question like this, or
Yes, of
only
course.
one. Oh,
All the questions in the statics, you have to start free body diagram. I guarantee you.
I mean, in here there is the free body diagram of the already 1,100, and the other one only the man. Do we have to make both of them, or only we can apply it immediately to the left one?
No,
The free
you have
body.
you have to do it both. You have to take a look at the man first, because if you just do it straight away, most likely most of you will miss out. I guarantee you.
Oh, I see.
Just now, if we talk about it, like some of you maybe just put it like not 1,100, but 800 only.
Yes.
If you just do it directly. But if you take a look at the free body diagram of the man, you can do it more accurate. Because the one that is supposed to be action and reaction, the one that is supposed to be put in the free body diagram of the beam is the reaction at the normal force here. Right? The normal force there, the normal force here, we got it 1,100 is because of the beam is giving a reaction force to the man, 1,100 going up in this particular free body diagram, 1,100 going up. So because of action and reaction, yeah, there is a 1,100 Newtons in this particular free body diagram at a beam going down because of action and reaction. So action and reaction is always like that. In the other free body diagram, the normal force is going up, 1,100. In the other free body diagram, the normal force is still the same, 1,100, but going down because of action and reaction. Do you get it, Ananda?
So the 1,100 is acquired by
the man free body diagram. This one.
The man's weight plus the force that he is giving to the rope.
Yes, correct. Because if you try to use your logic here, if we use 300, if the man is pulling 300 Newton, actually, the fact that is happening is actually he's being pulled by the rope, right? The man is pulling the rope,
yes,
but the rope is pulling the man as well. So actually, if we take a look at the man as our free body diagram, he's being pulled by the rope, 300 Newtons going back.
I see. Okay.
So
But
the
why
logic
there
is like
is? But why there is another 300? Why do you put another 300?
Oh, another 300 from this one. You can see it. There is a pin there.
Oh, there's a pin, sir.
Yeah, you can see it. The rope is like this.
Yes. Oh, because the tension are the same with the man pulling, it's 300 too. Yeah. Oh.
Yeah. So basically, actually, we have to draw three free body diagram, but I'm too lazy to do that. So actually, the other free body diagram will be like this: 300 Newton, 300 Newton, then like this, 600 Newton going down. So it's supposed to be 300 Newtons, right?
Sir, I'm sorry to interrupt, but we have a direct class after this.
Okay.
at
So
9
I think that's all for today. See you guys on Thursday. Please prepare for that quiz. Okay.
Thank you, sir. Thank you.
Okay, sir. Thank you.
Bye, guys.
Thank you, sir.
Thank you, sir.